Hello everybody, this is Mr. McNair, and this is 6.6 Special Products of Polynomials. Now, this section goes really well with section 6.5, which really all we did was FOIL, or use a distributive property. Well, we're going to do the same thing here. This problem, you already know how to do. Okay. However, the answer is going to come out in a way that we can actually skip some steps. All right. So if we were to FOIL this, we would take this 5t and we would multiply it into that second binomial. 5t times 5t, that's 25t squared. 5t times 2, that's 10t. So we did our first and our outside. Our inside, negative 2 times 5t, that's negative 10t. And our last, negative 2 times 2, that's negative 4. Now notice what happens here. When we combine like terms, we get 25t squared, because there's nothing like terms with that. 10t and negative 10t do what? Cancel. And then we just bring down that minus 4. So notice that our outside term and our inside term cancel out. Well, that will always happen when we have two parentheses, two binomials that are exactly the same, except one is a minus and one is a plus. Alright, if the two binomials are exactly the same, except one is a plus and one is a minus, the outside and the inside terms will always cancel. This is what we call the sum and difference pattern. The sum and difference pattern. You should know that phrase, sum and difference pattern. That happens when two binomials are being multiplied together. They look exactly the same, but one is a plus and one is a minus. That's the only time that it happens. Please don't do that with every problem. That's only going to happen with the sum and difference pattern. Now, for me, that means that when I'm doing a problem like this, if I notice automatically that I have a sum and difference pattern, I don't necessarily have to do the outer and the inner. I would just multiply the first together, get 25t squared, and the last, and get negative 4. Alright, and that will be our answer, because once again, I notice that these two parentheses are exactly the same, except one is a plus and one is a minus. Alright? Now, go ahead and try this one on your own. Alright, now that you've tried that on your own, let's go ahead and do this together. So notice once again, these two parentheses are exactly the same, except one is a plus and one is a minus, which means that we can use our sum and difference patterns. So that means I could just multiply the first together. 3b times 3b, that's 9b squared. And then our last, negative 5 times 5, that's negative 25. So there we go. That's our answer. Now, let's say by chance that you don't like this pattern, or you don't necessarily see how it works. You can still do the whole FOIL process and get the same answer every single time. In fact, you know what? Let's just keep that there. How about I just go ahead and, in blue, do the whole process. So if we did the whole thing, 3b times 3b is 9b squared. 3b times 5, that's positive 15b. Negative 5 times 3b, that's negative 15b. And negative 5 times 5 is negative 25. Add our like terms. 15b and negative 15b, those cancel out, leaving you with 9b squared minus 25. And there we go. That's our answer. Okay? So notice that we get the same thing. All right. However, using the sum and difference pattern might save you a little bit of time. Alright, let's move on. Here we go. 3n plus 4, that quantity squared. That does not mean it's time for you to go. Alright, that means it's time for me to go. So, what we do with this problem, and I'll explain this in further detail when I return, but you know how 5 squared means 5 times 5? Well, that's what this problem is asking us to do. We are not allowed to distribute this squared into the parentheses. You can't distribute that. Alright? If you remember from before, I told you cannot distribute an exponent into addition or subtraction. All right, so we can't distribute an exponent into addition or subtraction. So the way that we do this problem is we set it up knowing that 3n plus 4 squared means 3n plus 4 times 3n plus 4. Okay, and now we would FOIL this problem like normal. 3n times 3n, that's 9n squared. 3n times 4, that's 12n. 4 times 3n, that's also 12n. And 4 times 4, that's 16. Combine your like terms, we get 9n squared plus 24n plus 16. Okay? Try this next one on your own. Alright, after you've had time to try that, let's go ahead and do this one together. So let's just move this one out the way. Let's bring this over. So, once again, we know that this means 2x minus 7y squared means that we're going to multiply 2x minus 7y times 2x minus 7y. And now we're just going to FOIL. So 2x times 2x, that's going to be 4x squared. 2x times negative 7y, that's negative 14xy, because we're doing 2 times negative 7 is negative 14. X times y is xy. Alright, and then our inside terms, negative 7 times 2x, that's again going to be negative 14. Now, it doesn't matter if you put yx or xy, but you should know that those are the same. So I'm just going to leave that as xy, so that I know that these are like terms. Because remember, multiplication is commutative. You could change the order. X times y and y times x are the same. Now we multiply our last. Negative 7y times negative 7y. That's positive 49y squared. Then we're going to go ahead and combine our like terms. Like terms again being negative 14xy and negative 14xy. So we're just going to bring down this 4x squared. Negative 14xy and negative 14xy combine to be negative 28xy. So those are gone. And bring down that positive 49y squared. Right? And there we go. That's our answer. This problem is going to be similar to the last. Again, you know that 2x minus 3 cubed means that we're going to have this base written down how many times? 3. So this means 2x minus 3 times 2x minus 3 times 2x minus 3. Now going back to what we talked about in 6.5, this means that we're going to multiply 2 of the binomials together, get an answer, and then multiply that answer by the other binomial. So let's just concentrate on multiplying these two together. Alright, so 2x times 2x, that's 4x squared. 2x times negative 3, that's negative 6x. Negative 3 times 2x, that's again negative 6x. Negative 3 times negative 3, that's positive 9. Combine our like terms, we get 4x squared. These are like terms, so we get negative 12x. And then bring down that plus 9. I'm going to go ahead and scroll up a little bit here. Now we're going to take that answer and multiply it by this remaining binomial. So we're just going to bring that down. So we're going to multiply that by 2x minus 3. Once again, you can use your distribution method or your box method. I don't care as long as you show your work and your work makes sense. Alright, so we're going to take this 2x and we're just going to distribute it into the parentheses here. Okay, so 2x times 4x squared, that's going to be 8x cubed. 2x times negative 12x, that's going to be negative 24x squared. 2x times 9, that's going to be positive 18x. Then we're going to go ahead and distribute that negative 3. This negative 3 is going to go to everything over here. Okay? So negative 3 times 4x squared, that's negative 12x squared. Negative 3 times negative 12x, that's positive 36x. And then negative 3 times 9, that's negative 27. Okay. Once again, combine like terms. There's nothing like terms with that 8x cubed, so we're just going to write that down. And that's gone. Negative 24x squared and negative 12x squared, that's negative 36x squared. So those are gone. Positive 18x and positive 36x, that's positive 54x. So those are gone. And then once again, we're left with that negative 27 there. So we just brought that down. And that's gone. And there we go. That's our final answer. Okay? And there we go. That's 6.6. All right, ladies and gentlemen, have a great day.